Good day, everyone, and welcome to Pinnacle BIM Series Chapter 3. My name is Arvind Sharma, and I'm a reality capture specialist in Pinnacle Infotech. In this webinar, we will discuss about digital twin and reality capture of physical assets. Whether you are an expert in the field or just starting to learn about it, this webinar, of course, will provide you the valuable insights and information that you can use to enhance your knowledge and skills. We have three more speakers today. I would like to ask them to introduce themselves. I'm transferring the charge to Mike.
Yes, and thank you for having me. Arvind, thanks for the introduction, and I'm really glad to be here. My name is Mike Zivanovic. I work with Faro Technologies, and I'm based out of Chicago, Illinois, United States of America. At Faro, I'm a senior solutions architect, and my primary role is to work with our customers to ensure that the reality capture solutions we provide are fitting within their workflow and they're using them to their maximum potential. Faro is a reality capture company that's been around for over 40 years. And we started here in America, but we've quickly grown on an international level. And I think you'll see Faro scanners all over the world at this point. So I love everything about reality capture, and I'm really glad to be here. And I'm looking forward to a great conversation with everyone today. Thank you.
Hi, Leo. Can you introduce yourself? It's a great honor to be in a webinar to us.
Hello, Arvind. It's indeed my pleasure to be invited in the BIM series to discuss today regarding the digital twin and reality captures physical assets. So just a few words for myself as an introduction. My name is Leonidas Tzevelekas, and I'm a digital engineering manager for China Railway Construction Corporation Company, CRCC. So we are a global contractor. We operate around the world, and we design and build state-of-the-art infrastructure projects. So my specialty is in contracting. I have spent more than 15 years in delivering projects in a design and build arrangement. And it is indeed a great pleasure to be a part of this panel discussion today. Thank you for giving me that opportunity.
Thank you, Leo. Thanks again. Hugo, your turn.
Hello. Let me start thanking for participating in this session with such honorable guests. My name is Hugo Marques. I've been with Pinnacle in the last few years, implementing digital design technologies in different clients, mostly connected in the last years with aviation projects. I have an architecture background. I've worked in different design firms in different parts of the world, and it's a pleasure to share this conversation with all of you.
Thank you, Hugo. So guys, we hope you will find this webinar informative and useful. Without any further delay, let's get started. So I'm transferring the charge to Hugo for his words on digital twins. Hugo, over to you.
Yeah, thank you, Arvind. Yeah, here is a little bit a challenge to start our conversation, to understand a little bit our views about the implementation of digital twins in the AEC industries, and how, especially in large size infrastructures, digital twins can have an influence. Like I was mentioning in the introduction of myself, I've been working with aviation projects, and one of them is an infrastructure that exists for around 40 years, more than 40 years. We've been gathering the digital information about this facility. I think recently we surpassed more than 1 million drawings already in relation to this facility. It has more than 150 buildings that are considered valuable for managing their information with a database of critical assets, critical, not the total, but the critical assets are around 200,000 over a 4 million database of assets. So with these numbers, it passes the human capacity, and the digital twin, especially in this kind of large size infrastructures, I believe that is a tool that can support human decision in managing projects related with these large size facilities. I would share this opinion and ask our guests if their opinion and their views about how digital twin is in our industries. Mike, you want to start?
Yeah, and Hugo, I 100% agree with what you're saying, and a key word that stuck out to me there was you said human capacity. So oftentimes when we're thinking of BIM or the AEC in construction, we may be thinking of just one building that we're modeling, and we want to create a digital twin out of that. But oftentimes we don't think about an entire complex. We don't think about an entire a city or whatever it is that we're trying to manage here. So one team of people can manage one hospital without a problem, but to manage a multi-facility environment is very difficult. And me personally, I think of I credit Dr. Michael Greaves from the University of Michigan in 2002. Some say he coined the term of digital twin, but there is, and I'm glad we're having this conversation to make the distinction between what is a virtual twin and what is an actual digital twin. So great points, Hugo. I agree with you 100%, especially on the human capacity end. With all the data coming in, the metadata, how can digital twins help us assess all of that information? So I agree. Very well said.
Leo, any thoughts?
I do endorse the viewpoints that addressed from both yourself and Mike. So from my viewpoint and from the opportunity to deal with clients that request a digital twin implementation in their projects, I have come up with the conclusion that the digital twin is a requirement that engages the clients into a digital approach. Of course, some of the definitions about the twins, whether they are digital or virtual, it's a matter of debate sometimes, because we don't have yet a clear definition in the construction industry and subsequently on the operation and maintenance implementations of how the terminology will be offered to the clients. However, whatever the case is an opportunity for the clients to engage digitally in the project's deliveries workflows. And I see that it lays the foundation of creating an early digital database of any project, no matter if it is already executed, an as-built arrangement, or a brand new design project. So I see that the digital twin is, as a term, is engagement to deliver digitally. Thereafter, regarding the requirement itself of a digital twin implementation, it is upon the client's needs. So as long as the client is able to evaluate the requirements of having a digital twin in place, this will dictate to the supply chain the way, process, the workflows, and the procedures that this digital twin will be applied in any project for a tailor-made purpose, let's say. So this is so far my understanding. So we offer a multitude of options to the clients according to their own internal organization needs at the first place.
Hugo, one thing that I will another analogy I'll give a quick one is, When I drive my vehicle, so years ago, they would tell me, here in the States that every 3,000 miles you need an oil change. And we never had any kind of data to just tell me if the oil was still good in my car, but just every 3,000 miles you need to change it. But now with vehicles, as I drive my vehicle, I have an oil life meter that's telling me, okay, the oil life in my car is at 70%, at 60%, at 50%. And that maybe doesn't mean that I need to get my oil changed at 3,000 miles, but it's telling me almost as a digital twin would predictive maintenance on, hey, as the oil life is dropping, I need to start preparing to change my oil so that I can keep the maintenance of my vehicle correct. So to your point, before digital twins, we didn't know, we just assumed things, but now with the advent of digital twin, we're able to forecast, and that's something we'll talk about more in depth in just a little bit. But just wanted to add that analogy as well, just for those that are trying to understand what is a digital twin.
100%. Yeah.
Yeah, definitely. So Hugo, what are the fundamental concepts and components of digital twin? Can you explain, please?
Yes, I will ask you to pass this next slide. So basically, this is just a graphical representation of this spiral for key concepts. I mean, do we need to have BIM to have a digital twin? We definitely need digital engineering methodologies that allow for these collaboration processes and collection of information and exchange between the different parties involved in the project. Of course, if we think in the CAD drawings, in a 3D model, and schedules of information separately, we are before, for instance, what BIM already gives, because BIM already combines and structures this information in a single source. So BIM is a better starting point. But the assets exist in reality. So we need to understand their as-built condition and to have a better representation, virtual representation in the model of that physical asset. That's where the reality capture enters to allow this representation to be more accurate from the actual physical building or facility that BIM is trying to achieve. And when we think in this universe of combining multiple twins on a city level, on a country level, on a planet level, that is when it enters this concept of the smart cities. So this was to give a little bit of overview in these concepts, and I will ask Arvind also to pass to the next slide. This process of digital twin is not automatic. I mean, based on publications and industry investigations about digital twin, there are 5 key steps, intervals in this evolution of the digital twin. I use this one from the Australian references. There are different names to each of these stages, but they more or less establish these 5 steps. It starts with that initial one, descriptive, where we are collecting all this information and place it in a common database. A second step that we can call it informative, where there are starting to be relationships about this information. We know which building we are talking about, which level, which assets belong to building A or building B. So we start having a structure for that information. A second step where is interactive, where we have live actors interacting and updating this information. Then we evolve to the next step, that is intelligent, where the machine and the digital twin already help us to identify issues, common practices to optimize time. So it starts to be intelligent and be able to get conclusions of these data connections. And then the last step, that is this predictive, that he already can predict future scenarios and give us potential solutions for that purpose that we try to input. Things like we see now, this is a good example of this is this new tool, ChatGPT, where we input a bunch of questions and it starts using those questions to give us a conclusion and an output. So the digital twin in that last step is already a little bit this predictive analysis and possibility. Before passing to the next step, I don't know if Leo or Mike want to give their input on these structure fundamentals of concepts and these structure stages of digital twin implementation. Mike?
To be honest, I fully agree with this. This is a great way to describe it. We have an existing database that contains information. We're interacting with that database throughout the design process. It's intelligent. It can identify patterns. It can identify use case scenarios. How we are using it compared to its abilities, and then it's predicting when it needs to be maintained or when it needs our attention. So this role from beginning to the end is, I agree with Leo. What are your thoughts?
The only thing that I may add in this slide is that the digital twins is what we called a middleware platform. So it is an integration platform that it may require inputs from artificial intelligence algorithms and big data solutions, so that to reach to the level of making predictions, to reach to this advancement of intelligence, let's say, because the current objective is to move from the current approaches and use all the modern features and advancements of technology, so that the machine to be a machine learning process that will allow us to optimize and get the maximum benefit. So digital twins, I consider the term as in a broader, let's say, activity that will be embracing, integrating all the technological advancements of the today's, technology.
Thank you, Leo. So moving forward, we have collected a great figures on the benefits and analytics of digital twin. So Hugo, can you explain about it?
So yeah, this slide shows a little bit of analytics collected from these annual reports on the industry from DOGE and NBS organizations. Most of the numbers are more related with the operation and maintenance stage benefits, because of course we know that around more than 70% of the investment in the building life cycle happens on those stages. But we clearly can understand that digital twin will enable an increase in the production, especially in construction stages, minimize the amount of resources needed in many of the engineering processes, and with that bringing some cost reduction.
Moving forward, Hugo, can you explain the framework of digital twin, how it's synchronized, and what are the accuracy and frequency of it?
Yeah, so going back again to the purpose, I mean, we talk in the introduction about the medical surgery, the accuracy of the information in medical surgery or in space travel and air shuttles is fundamental. One error and the patient dies, or the travelers don't come to destiny. And this digital twin that is a replica of this physical twin, the frequency of its synchronization and the initial step of capturing the as-built condition of that building, of that asset, is a fundamental process in the digital twin framework. It's the key difference between the BIM model and the digital twin is that connection to the physical twin, and reality capture is one of the ways of accurately represent the physical asset in this virtual environment. And I believe that is something that we'll discuss next, how important that process is, and in the capture of the physical asset in a virtual environment to allow the digital twin and the constant updates of its status with the changes along the life cycle. I believe, Arvind, and correct me if I'm wrong, you for this World Cup event, these FIFA stadiums, so these large-scale facilities, you are involved with these workflows using faro equipment, and you could testimony these how this supported the creation of this virtual twin and contributed to the accuracy of the construction processes.
Yeah, actually, everything starts from the need. So when you identify the need, you are able to set out a strategy that it will be satisfying your needs. So in that stadium, specifically the stadium of the final games in the FIFA World Cup in Qatar 2022, we had a highly complicated steel structure that had to be fabricated in China and thereafter to be shipped into containers miles away to the state of Qatar. So we're talking about a fabrication package of 33,000 tons with highly complicated geometries, with a tonnage that it could not easily be handled or receive any corrective actions while you identify that something was not properly fitting on the section. So I had the chance by that time to work along with Arvind, Pinnacle, and Faro Products by that time, and we set out a strategy that it was covering, I would say, the entire spectrum of the laser scanning activity. So we have been using handheld laser scanners on the production level. So while the sections were under fabrication, the factory was undertaking a very in scrutiny some checks with handheld scanners so that to identify that their sections and their plates are coming within the predefined tolerances. Thereafter, they were making a trial assembly before they ship the packages to Qatar, so that to ensure that the section is coming to the appropriate shape and geometry. So in both phases, we have been using laser scanner, handheld, and terrestrial laser scanners for validating the geometries. So that was an intermediate stage that we as a general contractor by that time could have the confidence that the product that is shipped from the fabricator to the job site will satisfy the needs. So upon receiving the material within the proper specifications, tolerances, so on, okay, we could directly proceed with the assembly on ground, okay, as long as we have been creating segments of steel trusses and other members who have been undertaking some extensive exercises in monitoring the geometry of our segment prior to its lifting. So we have been using laser scanner to compare as-built conditions against lifting scenarios, if you allow me to say so. So that to identify that even our lifting process meets the requirements. We are talking about lifts of 400 ton, which we have been utilizing crawler cranes that of a capacity that may exceed the 1,000 ton, for instance. So generally speaking, the need of having a sophisticated approach created for us the plan to innovate. And we found ourselves into a process of planning, having an innovation perspective of how we can use the best possible technology available in the market with the best possible practices, okay, and thereafter to just coordinate all these actions so that to come up with a process that it's workable. Of course, within this process there is risk, okay, but on the same time, where there's risk, there is innovation, there is sophistication, there is all the process that make us, okay, move one step further. So specifically, the LiDAR method and the reality capture has proven results in the Lusail Stadium building in Qatar, and I consider myself very privileged for being a part of this process, and the knowledge that we can share today, even with that short description, is something that make myself, Pinnacle, and Faro, since we have been using Faro, very proud of the achievement.
Thank you.
For sure, Arvind, this changed this logic of field and office connection, because we were talking about the manufacture in China, the production in Qatar. So the logic of the connection between the office and the site was a big learning as well in this process, I believe.
Yeah, that's very, very true. And I can go beyond that. It's not only the different locations of undertaking the operation, it's also a part of the different stakeholders. So within this supply chain of the construction industry, we have to involve fabricators, we have to involve subcontractors, we have to involve the local supply chain, you have to involve lifting equipments, you have to involve yourself as a contractor that will be managing the works on site. And finally, you have to involve the client and the project management teams to entrust the technology for undertaking such a critical operation. So it is a process that the entire industry start getting itself into a learning process and moving, further with the implementations. But I think that I have said enough. We have Arvind on board, which was also a key player in this process. So I may request from Arvind himself now to make a comment on the process, please.
Thank you, Leo. Thank you for reminding me the time. So it's a great time that we have processed around 10 terabytes of data with around 2 or 3 mm of accuracy in Faro sister software that Faro seen. So we have exported in several formats to use in different applications, just to compare with the BIM models, to create meshes, to create fly-through videos, and to extract the coordinates mainly for the brackets and many more. So this is what we have done. So there are some key challenges that attest to this technology for now, that includes the time and power needed for the processing of the data to convert in a 3D model, and that I think we are moving to the AI tools, and as Mike also introduced a less time consuming Faro equipment that can scan within a minutes, and I think that's a great innovation in this industry. So Mike, your views on the new scanner, what you have introducing for a site, like it will be the Swift technology, or it's a terrestrial scanner, what it is?
Well, I can't release that information just yet, but I can. But it's right in line with exactly what you're saying. So going off of our Swift platform of fast scanning, but we're looking at ways to merge the Swift technology of quick scanning into traditional terrestrial scanners, where maybe a Swift cart would be hard to get around. But what we're doing is we are going to provide the same accuracy a lot faster than we've done in the past. And I think I can say that confidently without getting myself in trouble. But the fact that you're processing, like you said, 10 terabytes of data. I mean, that is an amazing amount of data. And if we look at the scan times itself, there's people out there performing 4-minute scans, 2-minute scans, whatever it is. We want to get those scans under 1 minute with the same level of detail. And I just want to take one quick step back and make a point on what Leo said, which is really critical here, is that they built this amazing structure in Qatar that was fabricated in China, brought over in containers, which is a logistical, just amazing to see that from a logistics process. But they're assembling pieces of that stadium on the ground, and then they're lifting that into place with lattice boom cranes, probably some Liebherr cranes, if I had to guess, which are among the largest cranes in the world, are on site, and they're scanning those pieces prior to them lifting them to make sure that they fit correctly. Well, I see that as momentum, as you have a piece of equipment ready to lift in, and the amount of time it takes to lift something like that off of the ground, swing it into place, to catch that piece, to connect it, and for it to fit perfectly, that takes a lot of time throughout the day for that one lift to happen. And if they were to lift that piece in and it didn't fit, now you're stopping all of the momentum that they've carried up to that point to get ready for that pick. So by us validating that data and making sure on the ground that, hey, what we've assembled is going to fit, that continues the momentum that you're building, which helps you impact project schedules. So Leo, I'm really glad you said that. But to your point, Arvind, our goal and what we are doing is our next step, and the next generation of Faro will be to capture more data as accurate as we've been doing it faster. And I know you have that curve of you can only go so fast and double what it is, but that is our next step, and we've already achieved that, and it will be announced very soon.
Thank you, Mike. So moving forward to the advanced applications, as I have introduced before. So it's like for the point cloud conversions, some AI tools, and for generative designs. So we have many tools, and that we have used and we are using in the Pinnacle also. It come from Recap, Faro Scene, Faro As-Built for creating the BIM models, and some Leica tools also. So if we talk about some more advanced for the conversion of the point cloud, we can say to convert in the meshes. That mesh can be used as a 3D model or in a cinematography as a background. So there are a lot of uses after that. So like Mike or Leo, like, do you have any tool that you can like share with our audience that can be increase the productivity?
Sure, and I think from our end, if I use Autodesk Plant 3D as an example, so I come from the heavy industrial oil and gas industry, and we use Plant 3D a lot. So what we can do is take that scanning data, that recap file, we can import that into Plant 3D, and then using our as-built add-on to Plant 3D, which is Plant 3D in Revit, but we can take that add-on, and now I can select points within that point cloud inside of AutoCAD, and it can partner with the spec that I've created inside of Plant 3D, and it can automatically pull from the spec catalog and put that geometry in. And I can select 2 pieces on the main of a piece of pipe and then 2 pieces on a riser. It'll automatically place that pipe in with the correct OD, the outside diameter, so it's the right size pipe, and it'll automatically place that fitting for us. And if your options are selected correctly in Plan 3D, it'll place the weld gap for you, and in a matter of minutes, you're ready to take that piece of pipe and take it to isometric settings and create drawings out of it. So there are ways that we can utilize additional software inside of Scene, As-Built Modeler, and As-Built, where we can start creating meshes and geometry and and actual items with data behind the metadata where we can extract useful information. Again, to Leo's point, which he keeps saying, which is great, to what are your needs? What is it that you need? What is the deliverable that you're looking for? Based on that question, you can go inside of the as-built software and extract the information that you need to help you be successful. Leo, I don't know if there's anything you want to add on to that. You've brought some great information so far to the webinar.
Yeah, thank you for allowing me to comment on this subject. I think that the current subject and the slide here, it is a subject having the greatest potential for evolving further. I'm coming from a viewpoint that I see all the benefits of the point cloud implementation into a model-based environment. We can make amazing things such as deviation analysis. We can create as-built models. However, I will emphasize that we may lack of interoperability and development. So far, it is a field that it can provide tremendous problem solving into the as-built modeling. It has a great potential. It needs further development, and I think it's a field that all the software house companies, along with developers, should focus, because it will give such a tremendous advancement, a tremendous boost in creating data-rich as-built by utilizing point clouds, that it may reach an involvement level that we never envisioned before. So I take it as the most promising field or the forthcoming activity after the great development of the LiDAR method. It may come as to follow the same, as long as we are decisive in implementing those solutions into the as-built modeling. So automation matters, and further development of all these software solutions, I think that necessitates.
Well said.
Yeah, thank you, Leo. So if we talk about AI tools and generative designs that uses the algorithms to generate multiple designs options based on the specific parameters, Hugo, can you explain about some idea about generative designs?
Yeah, I agree with Leo. I mean, this step that comes after the reality captures is the one that the industry is pushing, and is also a next step of evolution. How to convert this point cloud in a mesh, how the mesh can be optimized to identify individual objects, and then with the potential of generative design tools, how that object in design stages can be using the artificial intelligence, being a parametric object, so that is based on conditions. So those conditions based on your design intention, how to create better objects and better solutions. Of course, we have a recap that, for instance, as an example, that through a cloud system already supports to convert the point clouds into meshes. There are other applications from different vendors that start to bring some intelligence. So to recognize that mesh in that building context, in that location, that is a pipe, that is a beam, that is a column. So they start to have this kind of intelligence. And then, of course, the generative design, we are already aware in the moment that we have these objects that have a type identified and data, their dimensions, their materials. So the software using Dynamo scripting or softwares that are more connected with the products industry, like Fusion 360, can, based on the material characteristics or in the dimensions for the certain function, if we put conditions that our building or our room needs in relation to that equipment, can use can give us possible combinations of solutions. So this is there, is happening, is under evolution. Is not a mature product yet, but it is something that like Leo mentioned and like Mike introduced, that in the pipeline of Faro products is that next step. So we have the reality capture, we have this point cloud information, we convert it into surfaces that become intelligent objects, and with the data of those intelligent objects, being the dimensions, the material, we can use artificial intelligence to give us different design solutions with a range of what is the best solution for our condition.
Thank you, Hugo. Moving forward with the field data communication, how, like, as a ground user, how we transfer the data to the offices. So it's a great importance of that process. For not only the construction industry, but also for the mining and infrastructure and developments. Traditionally, the data has been collected manually, like using pen and paper, or if we talk about the inspections, but and it consumed more time, we can say. So to communicate with the easygoing applications, mobile applications on the field, we use in Pinnacle BIM 360 inspection tools, we can say, and to transfer the scan data. We, if we can say, we use same BIM 360 documents and the scene webs here. So it helps us in that transferring the data from field to the office in a real time that can process immediately on the softwares. In addition to the mobile apps, machine learning, if we add, is also being used to automate the data analysis process. Machine learning algorithms can be trained to analyze the field data, identifying patterns, or to provide the insight that would be difficult to detect using traditional methods. So like I want to ask the speakers from, like, if they have any great tools, as I know that Faro already have the web share to transfer the data between the clients. So is there any like enhancement in that? Leo, if you have any idea that we can discuss.
So far, the feedback that we usually get from the clients is to have integrated platforms. So BIM 360 has proved as a quite robust platform that integrates data sharing. We are talking about sustainable solutions that they eliminate the paper-based form of communications. They are extremely efficient. They improve largely the timing required for processing data. They centralize the data into one single backbone of information, and they eliminate drastically the paper-based mode of communications. So data mining is not anymore an issue as long as a digital delivery approach regarding the field application is adopted. However, the capability of integrating and visualizing field data online with point cloud integrated solutions is something that evolves and sophisticates the implementation further. So far, we have stuck with the BIM 360 application, which we found it as the most integrated process. Okay, that general contractors, clients, construction supervision consultants, and PMs are happy to implement with. Of course, there are many other solutions that they may address at least the minimum requirements. And the key challenge is to integrate by allowing other platforms to have interoperability with this process. It's quite challenging, but I think it's something that will allow us to just populate the field information with as-built related information.
So if we talk about some cloud processing on the point cloud data, Mike, do you have like the cloud processing on the point cloud data? It's more fruitful, I think, because it process on their own server. So, like your views on that, if we process the point cloud data on cloud.
Yeah, definitely. So, where we are at now is with using Faro Stream and Faro Sphere, which Faro Sphere is our repository, our cloud-based solution where we house everything, including web share projects. So it's important to us now with the use of Faro Stream, where as you're scanning, you have your mobile device, iPad or iPhone, connected to the scanner or Android device. And as it's scanning, you're seeing that scan in real time. And what it's doing is almost pre-processing the scan, so you can ensure that you're capturing the necessary data while you are scanning to ensure you're getting it right the first time. From there, all of the scans are being processed in real time immediately in front of you. Once you have a secure Wi-Fi connection, from that point, you will upload your processed project to Sphere. And from there, you can then pull that project down to Scene to complete the registration process and move it to whatever solution you're using for interoperability or communication. We look at BIM 360 has been amazingly successful. Autodesk Tandem is now, positioning itself as the cloud-based solution for digital twin assets and managing that. But from our standpoint, we are going from immediate processing on the job site while you are scanning to ensure that the accurate data is being collected, sending that process data up through the cloud, and those on site in the office can immediately pull that data down. So the time it takes from scanning to office is now exponentially less than what it was before. So we're very proud of our Stream and Sphere platforms and how it impacts project schedules and makes things a little bit faster.
Thank you, Mike, for the great information. Moving forward towards the reality, I would ask Hugo to discuss on the mixed reality and some virtual and augmented reality. Hugo, your views, please.
Yeah. In the previous slide, we were talking about the field survey. There is a main contractor I'm located in Dubai. So in the project here in Dubai, he used a robot from Boston Robotics, equipped with a portable scanner, and he followed a path using georeference to scan information. So he could identify critical points in the structure or in the equipment's location to reach the path and scan to verify, and this was in a construction stage, so in the progress of the construction, to identify common errors that were identified in other points from a normal process of clash detection on a BIM model. So the robot, the drone equipped with a portable scanner could follow the path and go to these critical points of the building services to identify if in the next nodes the previous errors that were captured were not repeated. But this means that we have a georeferenced model that is accessible from multiple platforms. In this case, the drone follows this information and is equipped with a scanner to capture this information, and then can be communicated to office with a vehicle like Autodesk BIM 360.
And Hugo, I'll just, while we're on this slide, I just want to talk about augmented reality for just a quick second. That we know that, with Apple sells 13 million devices a year with LiDAR technology. So we understand LiDAR is important. We now have the ability with it's very recent, our floor flatness application, that we can take a live scan with a Faro laser scanner, and almost immediately, within minutes, we can look at the flatness of a wet concrete pour and tell you if there's deviations in high or low that have to be smoothed out or filled in. And using augmented reality, we can place your iPad over the location, and you can see exactly where on the floor you either have peaks or valleys that you need to attend to. So we're taking the already technology established of augmented reality, partnered with LiDAR and reality capture with Faro scanners. And our floor flatness app has been it's been a great hit with civil contractors up to this point who are pouring fresh concrete or existing concrete. If you have an existing floor and you want to see the flatness of it and the deviations, the floor flatness app will do that. And it's a great use of augmented reality, which I'm a huge fan of. I love AR.
Thank you, Hugo and Mike, on their views. If we moving forward to the eye of BIM, that have a smart database of digital twin. Hugo, your views on this? How we manage this, the data of digital twin with the use of different applications.
Yeah, this is a menu of key functionalities. I mean, we talked about many of them among our conversation. So when we are identifying for our clients, and it's something that we need to say, the digital twin implementation should come from top to bottom. I mean, we need to think on the city level to come down to the building and the asset level, because this platform needs to combine multiple players involved in the process. So in that journey of the digital twin, it's important that it starts with the client and the different governmental organizational structures to implement these strategies. So when we reach the production level, we set up the guidelines, and we clearly understand the purposes of why we are doing it. And when we are choosing the database and the smart database platform, it's important to have these characteristics. I mean, the industry is evolving. I mean, we know that when we talk about linear assets, the BIM softwares struggle. That's why we have to implement a volume strategy, a subdivision strategy of the models and of the zones to clearly manage the information. This is already, the industry is already processing this, creating new ways of reading the software. As an example, GLTF format, that the level of detail of your models depends on the zoom in that you do to them. So if you are on a city level, you see one volume of information. When you get approaching your building, you see another volume of information. When you enter inside the building, you see the different assemblies of that building. So there are already file formats that allow this progressive processing of the data to be able to combine this information. So this characteristic of geolocator, the integration of the 2D information with the 3D information to analyze smart analytics, to get conclusions and take decisions about the performance of our project. And then enhanced capabilities for real-time navigation in these models with augmented reality and virtual reality. This is a menu of key things that we should look for when we are choosing the platform to build our digital twins. And the industry is evolving in many of the solutions. We mentioned here some from Bentley, from Autodesk, from NVIDIA, or other players that are in the market for digital twins for some time, that are exploring these capabilities.
Thank you, Hugo. From the speakers, Leo, do you want to add any platform for the digital twin so far you have used?
Not specifically a platform, because there are many out in the market that we can refer to. But I would like to just go beyond what we already discussed and just to put on the table for discussion some recent innovations that we have been dealing with regarding the health and safety integration into a digital twin system. So clients having a very decisive approach on how we'll be implementing digital twins, they're currently requesting us to prepare workflows and integrate, for instance, health and safety requirements within the entire implementation. In other words, they want to geolocate resources. Okay, so they need to know at any time how many workers and where they work within their job site. They need to know about their physical and medical condition. So other than a geolocation that is provided by a GPS sensor attached on their helmets, we integrate technologies like such as wristbands, which can take your, the vital signs of the workers and stream it online with the dashboard of our digital twin platform. It goes even beyond the augmented reality, which is the most common, let's say, application in terms of virtual adoption on site, and we do consider the holograms. So we recently have started collaborating with holographic table industry, okay, with developers that they develop holograms and holographic walls, so that for the clients to get another experience other than the virtual, mixed, or augmented reality. So there are plenty of opportunities to integrate. All of them goes along with the vision of your client. The client will engage you in the process of developing, processing, and supplying all these technological advancements in projects. From my end, what I see is that behind the BIM, behind the eye, we may add the eye for intelligence now, which make it even more powerful. It takes the information and boosting it into a level that we have not been experiencing before.
Yeah, completely agree with you, Leo. Mike, your views on this, so we can conclude after that.
I'll be honest, there's not much I can say that would top what Leo just said. I absolutely agree with everything he said, and for me to try to top that would not be possible. But what he says with going from information to intelligence is critical for us. That next step to be able to monitor our employees on the ground and ensure their safety and allocating resources correctly is something that we're not able to do at this point yet, and it's something that needs to happen, and it's evolving. But that's our biggest asset, is our people on the ground, and we need to do more to manage them, to support them, to ensure the whole life cycle of the project is being done correctly. So Leo, it was great to hear you say that, and very, very well said.
Thank you, Mike. Moving forward, we are concluding this webinar. So, Hugo, can you conclude with your views?
Yeah, I think it was a pleasure to have this conversation with Leo, Mike, and Arvind. I think we had some great insights about our industry, reality capture, digital twin, all these technologies and how to manage them. And yeah, it was a pleasure, and I hope for who assisted our webinar, they opened their minds and they got something beneficial for them in their journeys. Thank you.
Thank you, everyone. As the technology continue to advance, we can expect to see more innovative applications for digital twin and reality capture, we can say. Thank you for your attention, and I hope you found this webinar informative. If you have any further questions or would you like to discuss on this topic with us? Please do not hesitate to reach out to us. Thank you. Thank you, everyone.